Okay, and objective 2 is to divide numbers in scientific notation. We're going to follow the exact same steps on these, except instead of multiplying things like we did before, we're going to divide things now. Okay? Otherwise, everything stays the same. So we're going to start part A. We're going to have 1.44 times 10 to the 12th divided by 1.2 times 10 to the 8th. We're going to start by dividing the numbers. So I'm going to take 1.44 divided by 1.2. Okay, and we'll have to move the decimal over one time for each one of these. So it's going to be, how many times is 12 go into 14.4? Well, 12 goes into 14 once. And we get 2 and 4. Put our decimal point there. And 12 goes into 24 twice. Okay, so we get 1.2 for the first part. Then we need to divide the powers of 10. Okay, so we know we're going to use this number. Divide the powers of 10. Well, 10 to the 12th divided by 10 to the 8th. When they look like this, we subtract the exponents. So we get 10 to the 12 minus 8th power, which is 10 to the 4th. Okay, so we're going to use that number. And we're going to put those two things together to write in scientific notation. So 1.2 times 10 to the 4th power. And this is correctly written in scientific notation because the first number is between 1 and 10. So we are done with that one. Okay, let's go on to B. For B, we've got 3.0 times 10 to the 8th divided by 4.0 times 10 to the 4th. Okay, so divide the numbers. We're taking 3 divided by 4, which is 0.4 goes into 37 times. We subtract and we get 2 and bring down a 0, and it's 0.75. Okay, so we're going to use that number. And then 10 to the 8th divided by 10 to the 4th equals 10 to the 8 minus 4, or 10 to the 4th power. We're using that one. So now we've got 0.75 times 10 to the 4th. Okay? Well, again, this is not correctly written because this number isn't between 1 and 10. It's too small. So we need to rewrite this in standard form first. The exponent tells us to move the decimal 1, 2, 3, 4 times. So I'd fill this in with zeros. And I don't need the 0 out in front, so this is the same as just 7,500. Okay? Now I need to take that 7,500 and write that in scientific notation. So the decimal would go between the 7 and the 5. So it's 7.5 times 10. And we'd have to move the decimal 1, 2, 3 times because there's 3 places after the decimal. So it's 7.5 times 10 to the 3rd power for part B. Okay? Now make sure you've got both of those examples written down because I'm about to try to erase some of them. Okay? Especially part B here, so I have room to do number C. Okay, or letter C, sorry. So, again, make sure you got this down. I'm going to go ahead and try to erase this stuff here. And maybe we can get it all. Sorry, this process takes a while because I don't have a good eraser on this thing. So again, hopefully you pause the video to make sure you got all that stuff. Okay, and now that we're all clean here, we're going to go on to part C. And part C is 7.5 times 10 to the 6th over 2.5 times 10 to the 6th. Okay, well again, divide the numbers first. 7.5 divided by 2.5. Got to move the decimal over one time, so that changes to 75 divided by 25, which is 3. Okay, so we're going to use that number. Then 10 to the 6th divided by 10 to the 6th, that is 10 to the 6th minus, sorry, 10 to the, let's try that again. Okay, 10 to the 6th minus 6th power, which is 10 to the 0. Okay? So we've got 3 times 10 to the 0. Okay, we could leave it like that, but however, anything to the 0 power is what? We've always said anything to the 0 power is 1. So this is the same as 3 times 1, because anything to the 0 power is 1. So that is just 3. Okay? So 3 times 10 to the 0, or just 3. Alright, and we have one last example to do. Okay, example 4 says Earth's average distance from the Sun is about 150 million kilometers. Light travels at about 300,000 kilometers per second. We want to express both numbers in scientific notation and estimate how long it takes the Sun's light to reach the Earth. Okay, well, we know the distance and we know how fast it travels, so we have to divide those things to be able to tell how long it's going to take. So we need to take 150 million first of all and write that in standard form. Well, that's 150 million means 6 zeros after that, kilometers. Okay, and we're going to divide that by 300,000 kilometers per second. Okay, and estimate how long it takes the Sun's light to reach the Earth. Okay, well, we need to first write these numbers in scientific notation. So 150 million is 1.5 times 10, and if we put the decimal right here in 150 million, there are 8 places after the decimal. So 1.5 times 10 to the 8th. We need to divide that by 300,000. We take 3, or 3.0, times 10. And if I put the decimal in between the 3 and the 0, there are 5 spots after the decimal place, so it's times 10 to the 5th. Okay? Well, we need to take 1.5, divide it by 3.0, or just 3. And 3 goes into 1 0 times, 3 goes into 15 5 times, so that's 0.5. We're going to use that number. Then 10 to the 8th divided by 10 to the 5th is 10 to the 8 minus 5, which is 10 to the 3rd. So to put it in scientific notation format anyway, we're going to have 0.5 times 10 to the 3rd power. Okay, well again, the first number is not between 1 and 10, so we have to first write it in standard notation. So 0.5 times 10 to the 3rd means we have to move the decimal 3 times, 1, 2, 3, and fill in zeros. Okay, so that is about 500. Okay, and that's 500 seconds. So 500 seconds is the answer to this one. That's about how long it takes the sun's light to reach the Earth when it shines. Okay? Now, we don't have to write our answer in scientific notation because it's a real world application. If it told us to write our answer in scientific notation, then we would, but otherwise it makes sense to write it in standard form. Okay, 500 seconds. Alright, so there's all your examples. Best of luck on your homework.